Dear students, today we are going to see qualitative tests for phenol. So first we have to know how the phenol is. It is having one aromatic ring, that is benzene ring, that is directly connected to the hydroxy group. That's why phenol is otherwise called as hydroxybenzene. So what is the other name for phenol? That is hydroxybenzene. And here how the hydroxy group is connected to the aromatic ring, that is directly connected. So you should have a direct connection with hydroxy group. And now we'll see the qualitative tests for phenol. There are 5 tests. We'll see one by one. So first one is a litmus test, then ferric chloride test, Libermann's test, bromine water test, and finally Phthalein dye test. So what are the tests coming under that? Litmus test, ferric chloride test, Libermann's test, bromine water test, and finally Phthalein dye test. We'll see one by one. So first one is called as a litmus test. Here we are using litmus paper. So that litmus paper is used to find out whether the solution is acidic or basic. There are two litmus papers available. One is blue, another one is red. If blue litmus paper is turning to red and that solution is considered as an acidic one. So the solution which is turning blue litmus paper into red, that can be called as acidic solution. If a red litmus paper would be turned to blue, that solution can be considered as basic. So what is acidic? Blue to red is acidic and red to blue is basic. Now here we have taken phenol, and in the phenol we are dipping the blue litmus paper. While dipping, that would be converted to, that would be turned to red color. Already we have known blue to red means that is acidic. So that's why that indicates that phenol is acidic in nature. And already we have known carboxylic acid is also acidic in nature. Now we are comparing the acidity of phenol with carboxylic acid. So what we are finding out? So phenol is weaker acidic than carboxylic acid. So how can we tell this? So for this we are going for one test, that is if you are treating aqueous sodium carbonate, we are taking carboxylic acid, with it we are adding aqueous sodium carbonate. What we are getting? We are getting brisk effervescence. So and we have taken phenol and that is treated with aqueous sodium carbonate, we are not getting that effervescence. So that indicates that phenol is weakly acidic than carboxylic acid. Now we'll see the second test, that is ferric chloride test. Phenol is treated with a neutral ferric chloride, we are getting a purple colored complex. So here we have taken 3 molecules of phenol and that is treated with the ferric chloride, we are getting a purple colored complex. Other phenols are also giving colors to this test. If it is phenol or azoxanol or orthocresol or paracresol, we are getting violet color or blue color. If it is catechol, we are getting green color. If it is hydroquinone, we are getting violet or transient blue. If it is pyrogalal, we are getting blue. Then that would be converted to red. Now we'll see the third test, that is called as Libermann's test. This is otherwise called as Libermann's nitroso reaction. So for this, first we have taken phenol and that is treated with concentrated sulfuric acid and also sodium nitrite. So what are the reagents taken? Phenol, concentrated sulfuric acid and sodium nitrite. Now what we are getting? Yellow colored complex, that is called as quinone monoxide complex. So by the treatment of phenol, concentrated sulfuric acid and sodium nitrite, we are getting a yellow colored complex called quinone monoxide. Now with this, again we are treating phenol and sulfuric acid, same phenol and concentrated sulfuric acid, we are getting blue colored complex called indophenol. Now this on dilution we are getting indophenol, that is red colored product. With the indophenol we are treating sodium hydroxide, we are getting sodium salt of indophenol, that is blue in color. So what is Libermann's test? We have taken phenol that is treated with concentrated sulfuric acid and sodium nitrite. We are getting a yellow colored complex called quinone monoxide. With this, again we are treating phenol and concentrated sulfuric acid. We are getting a deep blue colored complex called indophenol complex. This on dilution we are getting red colored indophenol. On treatment with sodium hydroxide we are getting sodium salt of indophenol, that is blue in color. Now we'll see the reaction for this. So first we have taken phenol and with the phenol we have taken, we have added concentrated sulfuric acid and sodium nitrite. So while adding, what happens? Phenol in the para portion it is having carbon and hydrogen, no? So the para hydrogen, that hydrogen this Na, and from 2 oxygens 1 oxygen would be taken. So O, this Na and H, that is removed as NaOH. Now what is left here? We have only NO. So that NO is added to the para position. NO, no, that can be called as nitroso. So here it is added to the para position, no, that's why it is called para nitrosophenol. Actually it should be written like this. So this nitrogen has to connect with the carbon. So we are getting para nitrosophenol. Now with the para nitrosophenol we are going for tautomerism. On tautomerism what happens? From here we have OH, no, so that hydrogen is going to attack with the NO and that will be converted to NOH. So the hydrogen present here, no, that is going to attack NO and converted to NOH. So what is NOH? We have known that is called oxide. Here we have only oxygen, no, so in order to satisfy the valency of that oxygen, this single bond would be converted to double bond and we are getting a quinone complex. So here we are quinone. Here oxygen of the quinone is replaced by means of this NOH. Already we have known NOH is called as oxygen. Here we have only one oxygen, that's why it is called monoxide. Parent is quinone, that's why it is called quinone monoxide complex and that is yellow color. Now we have taken that quinone monoxide complex. With this again we are adding phenol and the concentrated sulfuric acid. So by that addition from the oxide we have NOH, no, that OH, and the para hydrogen of phenol that is removed as water. That's why this nitrogen has to connect with the carbon, I mean para carbon of phenol, and that is called as indophenol, that is red in color. Now with the indophenol we are adding sodium hydroxide. By that addition what we are getting, H is replaced by means of Na and we are getting sodium salt of indophenol and that is blue in color. So here first we are getting a product called as para nitrosophenol. That's why this reaction is otherwise called as Libermann's nitroso reaction. So now we'll see the fourth one, that is called as bromine water test. So what is this test? Phenol is treated with bromine and it undergoes electrophilic substitution reaction. So we are taking aqueous solution of phenol and that is treated with bromine water. So we are getting a white precipitate, that is here the brown color of bromine that will be disappeared and we are getting a white precipitate. So what is the white precipitate? That is called as tribromophenol, that is 2,4,6 tribromophenol. So here we have taken aqueous solution of phenol and that is treated with bromine water. We are getting 2,4,6 tribromophenol, that is the white precipitate. So here the brown color of the bromine would be disappeared. Now we'll see the last test, that is called as Phthalein dye test. So here we have taken 2 molecules of phenol and that is treated with phthalic anhydride in the presence of concentrated sulfuric acid. It undergoes condensation. Here the sulfuric acid, no, that is acting as a dehydrating agent. So one molecule of water is removed and we are getting phenolphthalein, that is colorless. So how we are getting phenolphthalein? Phenol is 2 molecules of phenol with phthalic anhydride in the presence of concentrated sulfuric acid. We are getting phenolphthalein, that is colorless. Now that phenolphthalein is treated with dilute NaOH, we are getting fluorescent. So how we are getting this? First we have taken 2 molecules of phenol and that is treated with phthalic anhydride. So by that addition the para hydrogen of phenol, here one para hydrogen, here one para hydrogen and this oxygen, all will be removed as water. That's why with the carbon, I mean with this carbon and this carbon would be united and we are getting phenolphthalein. So how the structure is, we'll see that. So that is the structure of phenolphthalein, that is colorless, and now with the phenolphthalein we have added NaOH, that is dilute NaOH, we are getting fluorescent. So how we are getting fluorescent? Here the bond between carbon and oxygen would be broken and here we have hydrogen, no, that hydrogen is here, this hydrogen. So this hydrogen is coming here and attaches with this and that will be converted to acid. So here we have that acid and in order to satisfy the valency of that oxygen, here that would be the single bond would be converted to double bond and within the ring instead of 3 bonds here we have only 2 bonds, that is called fluorescent. and with this we are adding excess of sodium hydroxide, we are getting colorless product. Other phenols are giving colors to this test. We'll see that. So if it is phenol, we are getting reddish pink color. If it is orthocresol, we are getting red color. And if it is metacresol, we are getting blue or violet blue color. If it is alpha naphthol, that is 1-naphthol, we are getting green color. 2-naphthol, we are getting faint green. Resorcinol, we are getting yellow green. And finally for hydroquinone, we are getting deep purple color. So that's all about qualitative test for phenol. Thank you.